Hey Geometry B, how's it going? In this lesson 1.4, we're going to be talking about intersections. In geometry, if figures intersect, then they have a point or points that are in common. Postulate 3. If two lines intersect, then their intersection is a single point. Example 1. Name the intersection of line AC and line DE. Well, if I look at line AC, which is the horizontal line, and I look at line DE, which is the slanted line that passes through it, I notice that they do cross each other. The question asks, name the intersection point. Where do they cross each other? And the answer is B. This right here is the place where the two lines cross each other. So the answer is point B. As we go to example 2, the diagram is a little bit more complicated. We have three lines, line M, which is here, line N, which is there, and line T, which is up here. Letter B. Name the intersection of line M and line T. If we review the postulate real quick, if two lines intersect, then their intersection is a point. So we have to ask ourselves the question, do lines M and T actually intersect? Do they cross each other? And if so, where? Well, if I trace line M with my finger and I trace line T with my finger, sure enough they do cross, and they cross right here. Point P. Letter C. Name the intersection of line N and line T. Line N is down here, it's the horizontal line at the bottom, and line T is the slanted line that comes down like this. Question, do they cross? And if so, where? Why don't you write the answer down and actually commit to it before I tell you what it is? Line N and line T intersect right here at point Q. And hopefully, most of you wrote that down. So before we move to the next screen, let's just summarize. If two lines intersect, then their intersection is a single point. Okay, geometry, now we're on the second screen. Just to review, if two lines intersect, then their intersection is a point. In our next example, we're going to consider a portion of a map of Tenafly, New Jersey. Perhaps some of you are familiar with this. A. Name the point where Cortlandt Place and Newcomb Road intersect. So let's look at the map and try to find those streets. So Cortlandt is right here. And then Newcomb is down here. I'm just shading a portion of the entire street. Now, question, do those two streets intersect? And if so, where? You'll notice that I've labeled in green some points all over the map. So what is the point at which these two streets intersect? The answer would be point J. Okay. Next, name the point where Cortlandt Place and Hickory Ave intersect. Well, Cortlandt is already highlighted in orange, so now I'm going to highlight Hickory. So I've got to find it. It's right in the middle, and I'm going to highlight that now with the orange pen. And my question first would be, do they cross? And the question is yes. And now the question is, where do they cross? And I know the answer is a single point. I just have to identify which point that is. Can you guess which it is? If you guess G, then you're correct. Now to letter C. Name the point where Hickory Ave and Eager Place intersect. So this might be a little more tricky to find. Hickory, here's Eager over here. What I'm going to need to do is maybe shade a little bit of Hickory down here, also in orange. And then Eager comes down like this, but the road comes to a T. It just stops, and then you either turn right or left. They still do cross. Eager does not continue, but Eager does intersect with Hickory at some point. Can you name the point at which these two streets intersect? If you guess D, you're correct. So remember, when two lines intersect, their intersection is a single point. So now we're on our third slide, and we are introduced with another postulate. And that is Postulate 4. It has to do with planes and how they intersect with each other. If two planes intersect, then their intersection is a line. Right now, you're all probably sitting in some sort of room at your house. Look up at the ceiling. It's an example of a plane. Look at the wall in front of you. Notice where the ceiling and the wall in front of you come together. There's probably a seam that runs the intersection of that ceiling and of that front wall. You can think of that seam as a line. Postulate 4. If two planes intersect, then their intersection is a line. Let's take a look at the fourth example. We have a pink plane B and a blue plane A. From the postulate, when two planes cross or intersect, then their intersection is a line. Well, the pink plane and the blue plane intersect at a certain line, and in this case, it's line CD. Don't forget your use of notation for the line, which is a mini line symbol written above the letter CD. Example 5 is a little more confusing because there's actually three planes going on at the same time. You could think of R, the yellow plane, as perhaps a ceiling, plane S as perhaps a floor, and plane Q, the purple plane, is sort of a wall that passes through the ceiling and the floor. Maybe it's extending up into the attic and down into the basement. Maybe that could be helpful to some people. Let's look at letter B. Name the intersection of plane Q and plane R. So we're focusing on the purple plane and the yellow plane. Two planes, when they intersect at a line. At which line do they intersect? If you said line GF, then you'd be correct. Don't forget your mini line symbol above. Notation is very important. Letter C down at the bottom. Name the intersection of plane Q and plane S. Now, plane Q is the purple plane, and plane S is the green plane. So kind of visually take a look, take a scan at the green plane, and then the purple plane, and see where they cross. According to the postulate, when two planes intersect, they will intersect at a line. Which line do you think it is? I think it's line EH. And now on to our fourth and final slide. In slide number 4, we dig a little deeper into postulate number 4, which is the intersection of two planes. As a reminder, it's written at the top of the slide. Postulate 4, if two planes intersect, then their intersection is a line. There are two examples on this page. We're first going to focus on the left-hand side. Shown below is a rendering of the Freedom Tower, which is located in the financial district of New York City. Now, I also introduced in this problem a new notation. This upside down looking N thing, which is right here, this is a symbol that means intersection. So let me just write that for you. Some books will use this instead of writing the whole word. That little symbol means intersection. So in question A, what they're really asking is, where does plane ABD intersect plane DBE? Now this building is very, very interesting, especially the way that the architect plays with the concept of a plane. Really, really interesting, and perhaps it's almost like an optical illusion. If you look at it, it sort of like messes with your head a little bit. So plane ABD is the side of the building that seems like it's over to the left. Okay? And then plane DBE is right in front of us. DBE, it's this triangular face right in front of us. Now, according to the postulate, when two planes come together, they come together in a line. So try to identify what that line is and even write it down as I highlight it with my virtual pen here. So ABC is the left side that we see, and DBE is the front. And the way that I see it, these are coming together right here, and what I'm highlighting in green for you, right there. So what is the name of this line right here? I would call it line BD. You have to imagine that the architects of this building probably did pretty well in their geometry class. This is really a very, very interesting study of planes and how they're used in everyday life. Okay, letter B, plane DBE. Once again, this is this plane that's right in front of us. It's the closest to us. And then we're going to intersect that with plane BCE. Now, plane BCE is sort of a little bit to the right of that frontmost face or that frontmost plane. So I'm going to use a different color here just so we're not, overwhelmed with everything going on in the picture. But I'd like you to try to identify that intersection before I go ahead and highlight where they do come together. So DBE, the plane in front, and plane BCE, the plane that's over to the right, they come together, and you may have already guessed this. That line's not quite on the crease, but hopefully you can get what I mean. Those two planes intersect at line BE. Okay, and for our final example, example 7, I gave you an example of just the inside of a room. And instead of referring to the planes with 3 letters or a capital letter, this is the ceiling, this is the left wall, this is the right wall, and this is the floor. I just chose that instead of using letters to name the plane. Because in reality, if you were going to the Home Depot to describe something to the salesperson, you might say, oh, where my ceiling comes together with the wall, you're not going to say plane ABC. So here's a case where we might use some real terminology. So in letter A, we want to find the intersection of the ceiling, which is a plane, and how it intersects with the left wall. Now when 2 planes meet, they meet at a line. So look at the ceiling, look at the left wall, and see if you can write down the line before I do. I don't know why that symbol is going up on an angle like that, but I'll work on it for the next one. Okay, letter B, the left wall and the right wall. So focus on the left wall, focus on the right wall, and see where they meet. See if you can write it down or even just think about it before I write it down. Oh, that arrow is way better than the one above it. Letter C, the right wall and the floor. So here's the right wall over to the right, surprise, surprise, and here's the floor. Now try to identify where they come together. I think it's EF. And finally, this is a little bit of a trick question, but maybe some of you will be able to anticipate the answer before I reveal it. Find the intersection or the points that are in common between the ceiling and the floor. Well, if you just look in your own room that you're in right now and you look at the ceiling and you look at the floor, hopefully they're not ever going to meet. Those are called parallel planes, and there's never going to be any points in common because they run parallel to each other. So since there are no points in common, I'm going to do the no solution symbol, which is a circle with a slash through it. Okay, so in section 1.4, there are two postulates to summarize. If 2 lines intersect, they're going to intersect at a single point. Postulate 4, if 2 planes intersect, they're going to intersect at a single line.